Welcome back to another video, Finding RF Values Required Practical Practice Question. By the end of this video, you will be able to use chromatography to identify substances. Now, let's see here together how can a chromatography be done in the lab. We have seen the virtual version of the chromatography. Now we're going to apply the real chromatography in the lab. Here is how you prepare your chromatography paper. First of all, you need a starting line parallel to the bottom of the paper on which you are going to put dots for all your known compounds and your unknown mixture. Make sure you do this in pencil, as pen would smudge and travel with the solvent. Then, label where you're going to put each substance along the line. We have 4 pure compounds, A to D, and an unknown mixture, U. Use a capillary tube to dot each substance at its labeled spot. We actually could have done with spotting them a few more times to get stronger colors. So when you do it, lightly press on the capillary tube to where you want to form your dot. Let it dry a few seconds and then press it again a couple more times. This way you can get a stronger color, as you can see here. Without making the dot too big, of course, because you don't want your dots to overlap. Make sure you use a different capillary tube for each substance. When you're done, tape the top of your paper over a splint or something similar so that the paper can be suspended into the beaker. Now we're putting a small amount of solvent. The solvent needs to be touching the paper, but you don't want its level to go as high as your starting line. The solvent in this practical is water. Compounds are more soluble in some solvents than others, and remember, the more soluble a compound is, the further it will travel at the paper. Water is found to be a good solvent for these compounds because there are different solubilities. Mean that they travel up the paper at varying distinguishable distances, which you can see happening now. Now we fast forward the video to get to the end of this chromatography. Once the different spots have traveled up the paper to these different distances, and before the solvent reaches the top of the paper, take it out and suspend it to an empty beaker to dry, as we're gonna do here. We remove it and we put it in a dry beaker in order to dry. It is a good idea, before the paper dries out completely, to mark the solvent front before you can't see it anymore. Then draw a circle around each of them. Then draw a circle around each of your compounds and place a dot in the middle of them. Measure the distance from the starting line to each of these dots, and then finally measure the distance between the starting line and the solvent front. So here is a photo of the final chromatography paper. Now we are going to calculate the different RF values. Remember, RF is calculated by dividing the distance traveled by the compound by the distance traveled by the solvent. We found that the distance traveled by compound A was 59 millimeters, B was 45 millimeters, C was 62 millimeters, and D was 49 millimeters. And the distance traveled by the solvent was 63 millimeters. So we work out the RF of A by dividing the distance it traveled with the distance of the solvent traveled. And that gives us an RF value of A of 0.49. This is the RF value of compound A. We can repeat that method for B, C, and D, and we get these RF values. The RF value of B is 0.71, that of C is 0.98, and that of D is 0.78. Mixture U produces 2 spots, which means it contains a mixture of 2 compounds, as you can see here. We are going to call the bottom spot U1 and the top spot U2. The RF value for U1 is 0.78. and that of U2 is 0.95. Now we can see that the RF for U1 is the same as the RF of compound D. That means the unknown mixture U contains compound D. We can see that also the value of U2 is very similar to that of the RF compound A. So that means also that U contains compound A as well. So mixture U contains the two compounds A and D. This is how we use the RF values, and this is how we use chromatography in order to identify the unknown mixtures by comparing their RF values to known compounds.